Hello, let's take a look at equation of a tangent line problem. So the question asks, find the equation of a tangent line to f of x equals our polynomial there at 1, -4. Alright, so a tangent line, that's where it's going to touch this graph of f of x at one point, and it's going to have the same slope of the graph f of x at 1, -4. So I'm writing the equation of a line. You need two things. You need your point and a slope. It's because you're going to use point slope form, which is y minus y sub 1 equals m times x minus x sub 1, where y sub 1, x sub 1, that comes from the point, which in this case is going to be 1, -4, because our line is going to pass through 1, -4 as requested. And then m is your slope. So I just need to find the slope at this point of this function. Okay, and you need to equate this idea of slope with derivative. As soon as you hear, I need to find a slope, you need to think, I need to find a derivative. So this question for right now boils down to, what is f prime of x? What is the derivative of our function? Okay, so we're going to find the derivative and then find what it is at 1, -4. Okay, so let's look at our function. It's not quite just a string of power rules, because in this case we have one function here and another function here. Since f of x is already used, I'll change that to kind of have a g of x times h of x. When I have the product of two functions, I can't just split that up and take the derivative of g and then multiply it by the derivative of h. It's actually a little bit more complicated, but not too much more. It's actually pretty easy. So we have something called the product rule, and I'm going to put it right here front and center. It's saying if I have a function that is the product of two functions, the derivative of it is equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. So notice how we take the derivative of each function, but then we always multiply it with the original of the other function. Okay, so in this case, to keep with how our function is called f of x, I used f of x as the base function and g of x times h of x. A lot of the times you'll see the derivative written as f prime of x times g of x plus f of x times g prime of x. Or you might see it even slicker as f prime times g plus f times g prime. Okay, and all those are the product rule. But it's easier to think of it, so you don't get messed up with that f, g, h and stuff. It's just the derivative of the first function times the second plus the first function times the derivative of the second function. Okay, so let's look at that in action. F prime of x then is equal to, I'm taking it real slow here, d dx of x cubed plus 4x minus 1 times the second function, which is x minus 2, plus the first function, just as it is, times the derivative of the second. And I put that d dx there, so that now we go through and we take the derivative of it. And this is now just a string of power rules. So it's 3x squared plus 4, the negative 1 goes to 0, times x minus 2 plus x cubed plus 4x minus 1. Take the derivative of x minus 2, and that's just 1. So now we can go through and we can FOIL this. So I get 3x cubed minus 6x squared plus 4x minus 8 plus, this is easy, it's all just multiplied by 1, so not too much changes. In fact, nothing at all. And now combine like terms gives me 4x cubed minus 6x squared plus 8x minus 9. And there, we found our derivative. Okay, so the product rule is not too bad at all. You just take the derivative of the first function times the second plus the first function times the derivative of the second. So now we need to find the slope at 1 comma negative 4. That means I need to find f prime of 1. And what does that equal? So you plug 1 in for every x in your derivative, and then simplify. Okay, so this gives me 4 minus 6 plus 8 minus 9. It's always nice when you can plug in 1. Makes it a lot easier. So I get negative 3. So f prime of 1 is negative 3, which means our slope is negative 3. So now we can descend from calculus and just work with some nice algebra and write the equation of our line. So y minus negative 4, so y plus 4 equals negative 3 times x minus 1. We'll solve for y, so I'll distribute on the right side and subtract 4. And here's the equation of our tangent line. Okay, let's try another example where we have to use the product rule. Here we are asked to find the derivative of this function, but notice how this time it's the product of 3 different functions. And what's kind of cool about the product rule is it extends to however many functions you have. It's just you take the derivative of each of them and multiply by the other 2 functions. So what I mean by, in this case, the derivative is going to be equal to f prime of x times the second function times the third function plus the original first function times the derivative of the second times the original third plus the first function, the original second function, and the derivative of the third. Okay, so notice how looking through this, we take the derivative of each part of it and always just multiply it by the other 2 original functions. Here we go. Let's find the derivative of f prime of x. So first I'm taking the derivative of the first one, 3x squared minus 1, a couple power rules, and then the laborious process of rewriting the other 2 just as they are. And then we run through it again, and you add between it. You take the original function of the first times the derivative of the second times the original third, and then one more time plus the original first function times the second function, the original one, and then we get to take the derivative of the third one, 2x plus 1, and that's our derivative. Now of course I could go through this and multiply all that together, do some nice foiling and distribution, but I'm just going to stop there and look at our wonderful new derivative. And that can extend to 4 or 5 if a function has 4 products, 4 functions multiplied together, or 5 functions multiplied together. The same pattern just extends. You take the derivative of the first times the other ones, plus derivative of the second times everything else, plus the derivative of the third times everything else. And you can go on ad infinitum. Okay, I hope that has helped your work with the product rule.